So hello everybody and welcome back to a brand new video, and in this video I'll cover problem C, schedule management. That was from round 131, Div2. So let's get started. I will also make a video on problem D, so stay tuned for that as well. So in the following problem we have been given two integers, n and m, where both of them are of order 10 to the power 5. Here n is the number of workers that we have, and m is the number of tasks that we have to do. So let's say the tasks are a1, a2, a3, so on up to a of m. Every task has a preferred worker, right? Every task has been given a preferred worker. For example, let's say preferred worker of a1 is 3. So if 3 tries to solve task a1, it will take him 1 hour. So if a preferred worker solves a task, it will take him 1 hour. On the other hand, if some unpreferred worker, let's say if worker number 5 tries to solve this task a1, it will take him 2 hours. So if unpreferred worker tries to solve a task, it will take him 2 hours, right? So we have these n workers and we have been given m tasks where every task has some preferred worker, and we have to efficiently assign these n workers to this m task and do this task do this task in minimum amount of time. So we have to find the minimum amount of time that is required to solve these tasks using n workers. And if you have seen my previous videos, I have always talked about that if you have to minimize something, you have to maximize something, the very first thing that you think about is binary search. So here again we have to find a minimum or a maximum. So again you should think about binary search. I think there is also a greedy approach to the problem, but I won't recommend to solve these using greedy because greedy will only help you in 1 or 2 problems. But if you work on your binary search, you will be able to apply binary search to a lot more problems, and that will help you a lot more in your future, right? So I will only talk about the binary search solution. If you want to see a greedy solution, I will recommend reading some more solutions under the comments or somewhere else. Yeah, so let's start with the binary search solution. How can we apply binary search on this? So first of all, let's try to draw a graph and let's see if we can apply binary search on this. So if I try to draw a graph, here on y-axis I will say if we can do all tasks, right? There is my answer, right? That is the minimum amount of time. Obviously my answer is the minimum amount of time, right? So if my time is less than answer, I will not be able to do all the tasks. So the answer on this side will be no, right? So for example, if my answer is x, then I will not be able to do all my tasks in x minus 1 time, because if I am able to do all my tasks in x minus 1 time, then my answer will be x minus 1, not x, right? So on the left side of my answer, my value will be no, right? And now if you think about the right side, that is answer plus 1. If you are able to do all tasks in answer time, obviously you will also be able to do all tasks in answer plus 1 time, right? So on this side the answer will be yes. And as you can see, there is a clear line. Our answer divides these two blocks in no and yes, right? So you can easily apply binary search. And find this answer because it clearly separates your no and yes block, right? And this is how binary search works, right? So now the point is, how do you check if you are in the yes block or you are in the no block, right? So now we have to check no and yes. How do we find this no and yes? So how can we do this? So let's see. Let's say my current time, let's say I am somewhere here, right? Let's say I'm trying to find some random time x, right? I am taking some random time x, and I have to tell if this x lies in the yes side or this x lies in the no side. So how can you check that? So our time is equal to x, and we have n workers, that is worker 1, worker 2, worker 3, so on up to worker n. And we also know our values of a1, a2, a3, so on up to a of m. So among these I will count how many tasks prefer worker 1, right? There will be values 1 1 here. So I will count how many tasks prefer worker 1. For example, let's say 5 tasks prefer worker 1. Right. Similarly, let's say some 5 tasks also prefer worker 2. That is, there are 5 values that are 2 here. Right. Similarly, let's say there are three tasks that prefer worker 3. And so on. For every worker, I can count the number of tasks that prefer the following worker, right? So for so on, I will count, for example, let's say for nth worker, there are 4 tasks that prefer worker n. So I will keep a frequency of all these workers, right? All these tasks that prefer a specific worker. So now my time is equal to x, right? So I have x seconds. So my worker 1 will work for x seconds. So now I have to efficiently assign these x seconds to my worker 1. So first of all, I have 5, right? I have 5 tasks that are preferred to worker 1. So I will be able to do all these 5 tasks in 1 hour. So I will compare my x with these tasks. So there are 3 cases. My worker 1 currently has 5 tasks, right? And the time he has is x, right? The first case is that time x is less than the number of tasks that the current worker has. So let's say my x is less than 5, right? My x is less than 5, so I will not be able to do all my 5 tasks, right? So I will be able to do some of them. For example, let's say x is equal to 3, so I will be able to do 3 tasks here. But then I will have 2 tasks left, right? So I will keep a left counter that my 2 tasks are left, and some other worker has to give their 2 hours and do these tasks. So some worker has to give their 2 hours and do this following tasks. So left is now equal to 2, right? The second case is that my allotted time x is equal to my tasks, right? So my x is equal to 5 for, let's say. Then I have 5 tasks, right? And my x is equal to 5. So I will be able to do all my 5 tasks, right? So I have no leftover tasks now. So no other worker has to give their time to do my tasks anymore, right? So that's the second case. And you don't need to do anything here, right? Because there is no leftover tasks as well, and you completed all your time to do all your tasks. The third case is, let me write here, case 1, case 2, and case 3. The third case is when time x is greater than your tasks, right? So you are worker 1, right? You have 5 tasks. Now let's say you have 7 hours, right? Let's say your x is equal to 7. Now in first 5 hours you will be able to do your 5 tasks, right? But now you have still 2 hours spares, right? Because you had 7 hours, you spent 5 hours doing your own tasks. Now you have still 2 hours left, right? So now you can give these 2 hours to help some other worker, because if some other worker has some leftover task, you can help that worker. So if you have, let's say you had x hours, right? After doing your own task, you had some y hours left, right? You had some y hours left. Then you will be able to do y by 2 extra task of other people, right? You will be able to do y by 2 extra task of other people. So I will keep another variable that is help, and I will add this y by 2 to help. That means I can help y by 2 other tasks. I can help y by 2 other tasks, right? So these are the 3 cases. So this was what I did for my first worker. You can do the same thing for your second worker, and you can do the same thing for your third worker, and so on. So I will do a kind of dry run, and I will show you how it will work. So let's take an example from the question itself, and we will do a dry run, and I think that will help you understand it better. So let's take the first example, or we can take some other example. let's take the first example itself. So we have 4 tasks, that is A1, A2, A3, A4, and we have 2 workers, 1, 2, 1, 2. But I think the answer in this will be very simple. I don't think it will help. So let's try to do the second example. Right. So we have 2 workers and everyone has a preferred task of 1. So now we have to find the minimum amount of time that is required to solve this. So obviously the lower value will be 1, right? That's the minimum time that you will require to do all the tasks, and the higher value will be 2 times m, right? Because if one worker does all the tasks, in that case you will it will take 2m time, so your higher bound will be 2 into m. So you can say 2 into 4, it will be 8 hours there. So your lower bound is 1 hour and your higher bound is 8 hours, right? So you will start your binary search while low is less than equal to high, right? And your mid will be equal to low plus high by 2, and then you have to check. If check mid, here your check will give you yes or no, that is, it will give you yes or no. Yes, you are able to do all tasks, you are able to do all tasks. Otherwise you will give out no, that is, you are not able to do all tasks. So if you are able to do all the tasks, that means your current mid is your answer. Your current mid is your answer, and now you have to find a better value. So you will update your high equal to mid minus 1, and you will do high equal to mid minus 1. Otherwise, else you will your required time, the current time, that is mid, is not the answer. So you have to update your lower bound. So you will update your low equal to mid plus 1, right? So that will be a binary search. So let's simulate the check function now. Let's simulate the check function. So my lower value was 1, my higher value was 8. So my mid will be 8 plus 1 by 2, that is 9 by 2, that is 4. So my mid will be 4 first, right? So my time is equal to 4 hours. So now I have to check if 4 hours is enough to do all the tasks or not. So my task array was A1, A2, A3, A4. So my first has 4 tasks, right? So I have 2 workers, 1 and 2. My first worker has 4 tasks, right? And my second worker has 0 tasks. So I will start with my worker 1. Here, as you can see, I have 4 tasks, and my x, that is my time. My time is equal to tasks, right? So I will do all my tasks in my time, right? And I don't have anything left, so my left is still 0, and I cannot help anybody because I used all my time. So I cannot either help anybody, that is equal to 0. So my left is equal to 0 and my help is equal to 0 as well. Now I go on to the second thing. Here you can see my time is greater than my tasks. So I have 4 seconds, right? I have 4 hours and my tasks are 0. So I can help how many tasks I can help? 4 minus 0 by 2 tasks, right? So I can help 2 tasks. So my left is equal to 0 and I can help 2 tasks. So my help is updated 2. So now I have iterated through all my workers, and in the end I have my left is equal to 0 and my help is equal to 2. Left is the number of tasks that I need to still complete, and help is the number of tasks that other workers can help to complete. And as you can see, my left is less than help. My left is less than help, less than equal to help. Then the answer is yes. That is, I can complete all the tasks in time. So now if you see the logic here, if the answer is yes, I will update my answer equal to mid and I will do high equal to mid minus 1. So here the answer was yes. So my now answer is equal to 4, and my low is equal to 1, and my high is equal to mid minus 1. So my high is equal to 3 now. So if you do 3 plus 1 by 2, that is my mid is equal to 2 now. So now I have to check for 2 if the answer is possible or not. So for worker 1 I have 4 tasks and I have time 2 hours. For worker 2 I have 0 tasks. So I will start with my first worker. I have 2 hours, so I will complete my 2 tasks, right? But I still have 2 tasks left. So my left is equal to 2 and my help is equal to 0. Then I will move on to 2, right? 2 does not have any tasks, so it will have 2 spare hours. So I can help 2 minus 0 by 2, that is I can help 1 task. So now my left is equal to 2 and my help is equal to 1. So in the end, as you can see, my left is equal to 2, that is I still have 2 tasks that I need to complete, but my help is equal to 1, that is my my workers can only help 1 more task. So I will not be able to do 2 more tasks. So here my left is greater than help, so my answer is no, right? And as you can see, in the case of no, I will update my low equal to mid plus 1. So first of all, my low was 1, right? My high was 3, mid was 2. So now my low, now my answer is still equal to 4. My low will be 3 now. My mid will be 3 now. So now I have to check for 3. So let's check that. So now I have worker 1. It also has 4 tasks. Now I have worker 2. It has 0 tasks. Now my time is equal to 3. So I will do my 3 tasks in 3 hours and I still have 1 task left. So I will update my left equal to 1 and my help equal to 0 because I cannot help any tasks. So now my second worker has 3 spare hours because it has no tasks to do, so it can help other people. So it can help 3 minus 2 is 3 minus 0 by 2, that is it can help 1 more task. So my left is equal to 1 and my help is equal to 1. And as you can see here, my left is equal to 1, my help is equal to 1. Left is less than equal to help, that is I have 1 task left and my other workers can help 1 more task. So that worker can complete the left task and my all the tasks will be completed, right? So the answer here is again yes. So then my answer will be updated to 3. Now my low is equal to 3 and my high is equal to 2. So the binary search will terminate here and I don't need to binary search this any further. So that was the solution to the problem. And one more doubt that you guys must have is that, for example, let's say I have 3 workers and let's say I have X hours, right? Let's say I have X hours. Then some of you may have doubt that if let's say if X is less than number of tasks, then why are we doing all the tasks using X time, right? That means let's say here I have 6 tasks and I have let's say 3 hours, right? I have 6 tasks and I have 3 hours. So currently what we are doing is we are doing our 3 tasks using these 3 hours. But some of you may have a doubt that why are we doing our 3 tasks using this? You can do our 1 task and you can using those 2 hours help somebody other, right? But that is not optimal. How can you show that? For example, if you have 6 tasks and you have 3 hours, let's say you don't use your 3 hours on yourself, you use your 1 hour on yourself, and using your 2 hours you help somebody else. Let's say you have here 2 tasks, here 1 task. Let's say you help worker number 2 and you solve his task. But that is not optimal. Why so? Because if you are doing somebody else's task, right, then somebody has to help you with these 2 tasks, right? Because you used your 2 hours in which you could have done your these 2 tasks and you help somebody else. So now somebody else has to help you using these two tasks, right? And that is not optimal. Why? Because if somebody is helping you to solve these two tasks, he could have helped user 2, he could have helped worker 2 instead, right? So that's why first you use your hours on yourself, and if there are some hours left, then you use it on somebody else, right? I hope the argument is clear here, why we use first our hours on ourselves and then on somebody else. Because if we spend our hours on somebody else, then somebody has to spend their hours on us, right? And if that is the case, then the user that spent their hours on us, it could have directly spent those hours on worker 2 instead of spending it on us, right? So that was the whole approach. So if you want to see the code now, here is the code. Here I keep the frequency, right? The thing that you see here, right? Here I'm keeping track of number of preferred tasks of every worker, so that is my frequency. So I'm keeping a frequency of every worker, frequency of x plus plus. Then I do my answer is equal to 0, my low is equal to 1, I is equal to 2 into m, and then I do my binary search. That is can do, that is my check function, you can say. And then I'm updating my left and help, like I told you, right? That is that is the current time minus frequency, that is the number of tasks that we have. So I have if I have like let's say 7 time and I have done 5 tasks, then it will be 7 minus 5, that is I have 2 hours left. Then I can do 2 by 2, that is I can help one more task, right? And then I have left, that is frequency of I minus mid, that is if I have let's say 5 tasks and I have 3 hours, then I will have 2 tasks that are still left, so I need somebody else's help to solve them. So that will be 5 minus 3, that I still have 2 tasks that are left. And in the end, can do is equal to help, that is if the number of tasks that people can help with are greater than equal to number of tasks that are left, then the answer is yes. If the answer is yes, I will update my answer equal to mid, I is equal to mid minus 1, otherwise I will update my lower bound to mid plus 1, and in the end I will just print out my answer. So that will be the entire solution, and if you guys have a doubt, feel free to comment down below or join my Discord. I'm quite active there and I help people there. Yeah, so that was it. Also, if you guys don't know, Continue Newton School is offering a full stack development course. The course is over 6 months long, and it is totally based on pay after placement model, and you don't have to pay anything. There is 0 hidden fees, there is 0 upfront fees, and they are granting you a minimum package of rupees 5 lakhs, and the average package is rupees 7 lakhs, and the highest package is over rupees 26 lakhs. So it is a very great opportunity. Also, all their mentors are from top MNCs like Google, Flipkart, Zomato, etc. Also, they will get you placed into the top MNCs as well, like Google, Flipkart, Zomato. You can learn from the mentors that are working at those companies, and you can land a job at those companies yourselves. Also, you don't need to worry if you guys think कि यार मेरे को भी coding आती नहीं है, मैं भी fresher, मेरे को बिल्कुल नहीं आता है. The course is over 6 months long and they will teach you from scratch. So you can still sign up for this. And if you guys are looking for a career in the tech field, this is a very great head start that you should sign up for. And if you want to land a job, I highly vouch for this. And if you guys want to sign up, there will be a link down below and you can go and sign up from there. So yeah, be sure to sign up for this, and I will see you in the next video. Bye bye.